Welcome back, everyone, to the eCoreAcademy e-learning platform today. My name is AJay Raj, if you didn't already know, and I'm one of the main teachers here at eCoreAcademy. But of course, we've been expanding our platform, so we have many new teachers teaching their newest of courses. I've been here for a while with this anatomy and physiology course for you guys, and I'm really passionate about what I'm showing you guys in the utmost depth. I'm trying to break down complex topics, going into depth with them, but trying to break them down into the simplest terms for you all. And I really thank you all for your support. So before we jump into today's lesson all about the nephron in the excretory system in our anatomy and physiology course, please make sure to do 4 quick things right now. Please make sure to like this video if you haven't already. Subscribe to the channel, of course, if you haven't already as well. Turn on that post notification bell so you don't miss out on any of our channel's latest uploads and you stay up to date with every single one of our course videos. And also, please make sure to comment down below if you have any suggestions for future videos, future courses, and topics that you all are really looking forward to. And, just like those comments as well if you want to, so that they come up to the very top priority-wise. And also, any types of feedback that you have, maybe any issues that you see within the video that you want us to fix, or anything that you found confusing, we can, of course, publicly explain that so it can help everyone overall, and it can also help us and you individually. So really, we would appreciate if you did all 4 of those things. So now that you've done all 4 of those things, let's take a look at exactly what our video objective and our lesson objective is within this course and with this specific lesson. So just recapping very quickly on the excretory system, we've been looking at the excretory system within 3 videos now, essentially. We've started off with our excretory system overview, where I give you a giant essentially a collage of exactly what the excretory system is, trying to break it down into the simplest terms without going into too much specifics. So now that I've recapped that for you, we went into more specifics, according to the major structures of the excretory system. We went through structures like the kidneys, and then separately the lungs, and we have the ureters, the urethra, we have the bladder, and then we, of course, have the voluntary and involuntary sphincter muscles. These are all different components of the excretory system. So now what we're going to do is we're going to look at isolating a certain organ, a certain structure within the excretory system. And I like to think of it as the most important organ within this given system, and that is the kidney. So we're going to look at something that has to do with the kidney. I'm not going to give you any spoilers yet because I will explain it in the next few slides. But today's topic is all about the nephron. We're going to isolate that small unit, that small, essentially, structure within the excretory system. So, like I said, the goal and objective of today's lesson, we're all objective and goal-based here at eCoreAcademy. I want to make sure that you guys are clear on exactly what our objective is, our lesson objective. So our lesson objective is, let's examine what this unique structure, the nephron, is, and how it plays an important role in the kidneys and the excretory system alike. So obviously it has to do with the kidneys, and of course that affects the entirety of the excretory system and its success. So without further ado, let's move on. So let's give you guys a brief summary of what our previous video actually entitled us to learn. So the previous video was on the major structures of the excretory system, and if you haven't already watched that video, I strongly recommend that you watch that video before you watch this one. It gives you a strong recap of exactly what the kidneys are, and just coming in sequentially, a sequential order. It's very important that we look at that in that manner. So let's take a look at the just a brief summary of what exactly the functions of the kidneys are, and so that we can later analyze exactly what the nephron is. And just as a little spoiler, the nephron is a part of the kidney, and it's like the basic anatomical unit of the kidney. It's very important, and it's what makes up the kidney and its overall function worthwhile in terms of the excretory system and its entire process. So the kidneys have 3 primary functions, just as a brief summary from our previous video, and these 3 functions are filtration, reabsorption, and secretion. If we call upon, I'm not going to exactly give you a definition because I am going to go into more depth on their complex values in terms of the nephrons, but just as a summary, the filtration process occurs when essentially blood and other substance fluids within the bloodstream are being filtered out within the kidneys themselves. And essentially, this is where that good blood, and clean blood is being separated from other toxins, other waste materials within the actual kidney. And afterwards, you have reabsorption, where these good substances that are needed within the body, like excess glucose that are actually been filtered out, and also blood, are going to be reabsorbed back into the body. They're going to exit the kidneys, go and not necessarily exit the kidneys. That was just an example, but they're going to exit the kidneys' functions. They're going to go back into the blood capillaries and re-enter the bloodstream, meaning they're going to go outside of the kidneys. Through the capillaries and veins that are inside the kidneys. They're going to exit in that manner. And then, of course, you have secretion, which is the other end of the straw, where you have the toxic waste and the contents that are separated from these good substances that are being reabsorbed. They're essentially going to move out of the kidneys and turn into urine, mix with urea and uric acid. They're going to turn into urine. These waste products, and then they're going to exit the kidneys and go through the ureter into the bladder, where they're stored. That urine is officially urine and stored within the bladder, and then later program timed for release. And I've also gone over that, exactly how the bladder works and how it releases, with that voluntary counterpart in which you can choose when to release, and the involuntary counterpart where it decides when the actual bladder is full and where its capacity is met. So these processes allow for blood and other, just as a summary, these processes allow for blood and other contents of the bloodstream to be separated from toxins and waste, so that the blood can return to the body and the waste can be secreted. So, of course, we first have filtration, and then we have reabsorption and secretion. So essentially what's happening here is we have filtration as our motherly process of the kidney. That's number one thing you should know about for kidneys. In terms of the excretory system, of course, it can be involved in other systems as well. But for the excretory system, its main process is filtration, because that allows for its ending counterparts, which are reabsorption and secretion, which are opposites. So once you conduct filtration, you're separating the good stuff from the bad stuff. Essentially, your good blood, your arterial blood, oxygenated blood, your good substances such as your glucose, salts that need to be reabsorbed into the body, and then of course you're separating that from your toxic wastes and excess material that are within the body that actually need to be rid of, as well as that urea and uric acid that help break it down. So secretion is the other extent, and reabsorption is of course the opposite of that extent. All right, moving on. Now let's take a look at what the nephron is and what its correlation with the kidney exactly is. So just as a basic spoiler here, the spoiler is not much of a spoiler anymore because I've already given it away, but the nephron in general, this is the number one thing that you need to know. After knowing the basic functions of the kidneys themselves, you know that the nephron must be have some sort of process in terms of all three of those functions: filtration, reabsorption, and secretion. So the nephron is the basic unit of the kidney. It's what makes up the kidney and actually gives it all of its functions and properties. So the nephron is a glomerulus, or it's essentially, I'll explain what glomerulus is. It's a very important term, but it's essentially a gathering of nerve endings. But of course, I will have a diagram and definitions for that, exactly what that is. It's a group of nerve endings, and I know you guys are probably confused, but that does make sense in terms of the kidneys. Because what's the number one fluid within the body that's actually being filtered within the kidneys? That's actually blood. So your nerve endings actually help transfer that blood directly into the kidneys with the nephron. And these are little structures inside the kidneys with a glomerulus that essentially attaches to the nephron. And it consists of a thick membrane and a central tubule that allows for arterial blood, which is essentially oxygenated blood with good oxygen, to pass through as it filters its contents. So it allows for that blood to pass through and be reabsorbed into the body, reabsorbed into the capillaries in the bloodstream, essentially, and then allows for other contents to essentially exit, be secreted into something called a collecting duct, and that collecting duct helps dispose of those contents through urine and urea, mainly urea, and back out through the kidneys and into the bladder as urine. And it allows for chemical, as more of a biological, anatomical function. It allows for chemical balance and homeostasis. So it allows for that chemical balance within not only the kidneys, but the body and blood itself. And it conducts filtration, which will eventually secrete the toxins as urine that is passed into the into the bladder through the ureter, as I just said. So just to recap the whole process, what happens is the nephron, through those nerve endings in direct connection with the bloodstream, essentially, it absorbs arterial blood, which is your good oxygenated blood. And then what it does is it filters the blood through its central tubule, And once it filters that blood through the central tubule, it's also allowing for reabsorption, meaning it allows for exiting of other good materials, such as of course, your arterial blood, the good blood, and then other substances that are needed within the body. And then lastly, it separates waste and secretes urine once that whole process is done, and you're left with that urea and uric acid, which if you guys are confused, I'm going to do my very next video is going to be on urea and uric acid. So stay tuned for that. I did not want to go into too much depth and take a sidetrack from the nephron, but urea and uric acid are very important, and I will go into depth with that. But just as I recapped in my previous video, they are involved with breaking down these waste materials and turning them into urine, both of them. And essentially it separates the waste and secretes the urine at the ending part and the ending and exit process of the nephron. So now let's take a look at the different parts of the nephron, and I'll actually show you what it looks like. So part one. So these are the structures of the nephron. So the first main structure is the Bowman's capsule. This is the entrance point of blood into the nephron, in which the glomerulus, which is the network of nerve endings, as I said, which actually just essentially is the counterpart in which allows for blood to enter the kidney for filtration, and it brings blood into the compartment, the Bowman's capsule. The Bowman's capsule is mainly responsible for the filtration, the original filtration of blood. It allows for, through small net fibers, essentially in that small capsule, it allows for blood to pass through and filter out and separate its contents from blood and other necessary components that need to be reabsorbed. Then, of course, you have the proximal tubule, which is the long and narrow tube that connects the exit and entrance points of the nephron. So it connects the Bowman's capsule to what's called the collecting duct, which is the ending point. And of course, Bowman's capsule is your entrance point. It connects both of those points with a very long, stringy tubule, and it's where blood/contents are reabsorbed, also within the loop of Henle. So that's another structure that I will also explain. But what's essentially happening here is you're having blood enter through the Bowman's, you have your glomerulus, which is the nerve ending, transporting blood into the Bowman's capsule. And when the Bowman's capsule is, essentially absorbing that blood, it's allowing for blood to essentially filter through the Bowman's capsule and going through this proximal tubule. This proximal tubule's responsibility is to reabsorb all of the contents that are not all of the good contents, essentially. It separates, the Bowman's capsule separates the blood and good substances from the bad and waste products. So the waste products and the good substances. The proximal tubule only holds the good substances, and it will allow for them to be reabsorbed back into the capillaries and the bloodstream within the kidney and exits the kidney. And then, of course, you have something called the opposite, which is the distal tubule, and that's right around the proximal tubule, and that's what holds the waste products that will then go into the collecting duct and exit the kidneys. So, and as I said here, we have this important part. The loop of Henle is just a part of that proximal tubule. It's responsible for, it's where most of the time, it's the peak, essentially, of the proximal tubule, in which the contents of the proximal tubule are reabsorbed back into the bloodstream. So this is essentially where it utilizes its pressure, its blood pressure essentially here, and its pressure of contents to actually allow for contents to be reabsorbed back into the bloodstream, meaning pushed out of the tube. And of course, the pressure is greatest here, and it utilizes the differentiation of temperature. But don't worry, I will also go into depth on the loop of Henle because it's actually a very, very popular counterpart, and I did want to give its whole spiel later on. But just to give you a recap, it's what's mainly responsible for the secretion or reabsorption. Secreting good contents or reabsorbing good contents back into the bloodstream. All right, parts of the nephron, part two. We have the structures of the nephron continued. And then, of course, the other tubule that we have left is the distal tubule. It's the opposite of the proximal tubule, and it's the surrounding membrane of the proximal tubule that helps in excretion. So the proximal tubule helps with reabsorption, and the distal tubule helps in excretion and secretion, essentially. So it helps in secreting those bad materials, those waste materials, and helps transferring them, mixing them with urea and uric acid, and turning it into urine that's then secreted and into something called your collecting duct. And this is where waste is collected and later excreted and exits the kidney as urine and back into the bladder. So this is collecting duct where all that waste urine is collected and waiting to be transported out of the kidney. So, of course, just to recap what we just said, all of these structures, we first have the glomerulus where you get your blood. Then we have the Bowman's capsule, which is where the original filtration and separation of blood, arterial blood, and good substances from your harmful substances and your waste and toxic substances, just your waste in general, is being separated in the Bowman's capsule. And then, of course, we go up to the proximal and distal tubules. And in the proximal and distal tubules, they're basically opposite structures. The proximal tubule holds the good arterial blood and the good substances that need to be reabsorbed back into the body. And then the distal tubules hold the waste. The distal tubule holds the waste products that are going to be later excreted out of the body and out of the kidney. And then, of course, you have the collecting duct, which is where the distal tubule will then empty out its contents into, and then it will be transported out of the kidney. And of course, you might be confused, where does the proximal tubule release its items to? Well, just think about it. Like I said, there's nerve endings and there's blood capillaries all around the kidney. So what's happening is those proximal tubules are just releasing it back into those capillaries and back into the bloodstream. Those capillaries are part of the bloodstream. And of course, the cardiovascular system. And Anita will also go into depth with that in her cardiovascular videos. So you want to get to know more about the blood, how the bloodstream actually works with all systems. Go and check out what her cardiovascular system videos entitled. All right, now we have the nephron part 3, and we're going to look at a diagram, parts of the nephron. I'm going to give you guys a visual of what exactly the nephron looks like. All right, here it is. So we have the first part of the nephron, essentially. And this is your glomerulus, as shown here. And the glomerulus is, of course, where the blood actually enters through the into the nephron itself. And then, of course, here you have your Bowman's capsule, this large surrounding cup, and it is named after a very famous scientist. Essentially, he's a doctor. And I will go into depth with who he is. And also the loop of Henle is also named after a very famous doctor. And I'll also go into depth with them. So I'll make a whole separate video on Bowman's capsule and loop of Henle together. So then we have the Bowman's capsule, the filtration occurs. And of course, these blue arrows essentially represent your blood going through the nephron itself. Then, of course, we have the proximal tubule, which is the interior tubule, this yellow part of the actual nephron. And that's where the good blood and good substances are entering, and they're going to be essentially exiting as soon as you're going through this process, especially at the loop of Henle, which is also a part of this proximal tubule. And then, of course, you have your distal tubule, which is the exterior part of the nephron, in which it's all going to be collected at the collecting duct itself. By this time, all this blue arterial blood would have already been reabsorbed by now, and then the distal tubule, all the waste would have been pushed down through to the collecting duct right here. Now let's take a look at the functions of the nephron. This is where we're going to end off our video with. We have 3 more slides, just looking on 3 more complex functions of the nephron itself and how they actually relate to the overall kidney itself. So the first function of the nephron is glomerular filtration. So you might notice that, wait, isn't that the same as the kidney? Well, yes, the nephron follows the exact same 3 processes as the kidney: filtration, reabsorption, and secretion. But they're a little bit more complex because we're going to relate it to specific structures within the nephron. So first you have your glomerular filtration. That's the first filtration process. So glomerular filtration is when the collection of nerve endings dispense arterial blood, which is oxygenated blood, into the Bowman's capsule and begin filtration within the capsule itself. That's that filtration process where you're separating the waste products and the toxins and excess substances that are not needed within the body, need to exit the body. And urea and uric acid, you're separating from the good substances like your arterial blood and necessary substances. Like if your body is depleted of sugar, it's still going to obtain sugar and reabsorb it back into the body. Here, blood and necessary fluids and substances are separated, of course, from those toxic contents through the usage of uric acid and urea that turn it into urine. So just as an example, just as a clear visual here, we have the glomerulus, that group of collection of nerve endings is essentially dispensing blood into the Bowman's capsule, where the filtration is essentially happening through netted fibers. And I will also, all of these layers are actually more complex than you might think, but I'm actually gaining ground in more of a general term, but we will go into depth on exactly what this material is called. It's consistent through the entire kidney, what this filtration netting, this kidney filtration fiber is actually called, and how it filters blood from bad, essentially bad toxic waste. Functions of the nephron part 2, we have tubular reabsorption. So as you can see, it's the next process. It's the next part of the process. It's reabsorption. which is just like the kidney, but now it's tubular reabsorption. So this has to relate to the tubules within the proximal tubule specifically, and the loop of Henle within the nephron. So tubular reabsorption is when needed substances and clean blood move out of the proximal tubule to exit the nephron and release back into the body. So they go back to the capillary. So once they're traveling through the actual nephron, the proximal tubule itself, they then are released out and back into the capillaries, the blood capillaries, where they're then put back into the bloodstream. And waste contents are then prompted to be pushed back down the proximal tubule and into the loop of Henle, where this exchange is at its peak and water is reabsorbed back into the nephron. So one thing that I just want to get clear here, the proximal tubule is not going to be 100% pure, clean substances. It is technically going to be exiting some of its waste materials back into the distal tubules, where that waste is going to be collected. And likewise, the distal tubule is still going to have some clear blood, good blood with it, because that process by the Bowman's capsule is not going to be 100% accurate. So it's going to be some exchanges in between to make sure that the good substances are kept and the bad substances are essentially exiting. They're secreting and going to be excreted out of the body. And of course, you have the loop of Henle, which is responsible for both the distal tubule and the proximal tubule. So it has both layers to it. And this is where most of that exchange is essentially happening. And this is where water is also being reabsorbed back into the nephron, and it uses the least amount of energy possible. But don't worry, I will also go into depth on the actual loop of Henle and the Bowman's capsule as well. So just to give you a quick recap on exactly what I was saying, tubular reabsorption, what's happening here is you have your proximal tubule, which is on the inside. Let's label it first. So you have proximal, which is your inside netting. And then you have your distal, which is essentially surrounding its edges. So these guys are distal. And this one right here is your proximal. So distal, of course, just as a recap in reabsorption, in terms of reabsorption, it keeps all waste. So the distal tubule is essentially inactive at this point. It's still just transporting waste and collecting any excess waste in the proximal tubule. Then the proximal tubule is most active during this time, actually. It actually reabsorbs. So it's essentially reabsorbing. Reabsorption happens here, where it pushes out all the good blood and good substances back into the actual bloodstream, into the capillaries themselves. And then now for the final function of the nephron, we of course have secretion, just like the kidney secretion process, part 3 of the functions of the nephron. And tubular secretion is when the blood from the surrounding capillaries enter through the nephron. And of course, that's through the actual glomerulus. So the blood, essentially, just to summarize what I just said, all the blood from the bloodstream is essentially going through the capillaries within the kidneys, those just blood vessels, and it's essentially entering through the glomerulus, which is that collection of nerve endings that secrete it into the Bowman's capsule and into the nephron and pass it into the distal tubule. It separates itself from the proximal tubule, and waste is entering the distal tubule. This is where the distal tubule comes into play, and it empties itself out into the collecting duct. That duct where it actually clears out all that urine from the kidney and out of the nephron. So the collecting duct, of course, then excretes these contents from the distal tubule as urine once the urea, mainly. Essentially what I'm saying here is it excretes it as urea once the urea and it exits the distal tubule as urine, of course. That's the actual waste counterpart, just a lot of URs here. Once the urea and the uric acid, which is urine is mainly made out of urea, but it's also made out of uric acid, and of course those other combined waste products exit the kidneys, exit the nephron, and later exit the kidneys to be excreted. So of course here we have that example here. That's the final step towards excretion in terms of the kidneys, and we have the excretion process happens here once it exits the collecting duct and it connects to the actual counterpart, the actual capillary within the the actual cavity within the kidney that collects this, and then releases it through the ureter and into the bladder, where it's then, of course, excreted, going number 1, releasing it back into the toilet where it actually should clear out of the body. All right, everyone. So that'll be it for today's video, all about the Nephron. Thank you so much for sticking around. This has been the eCoreAcademy Learning Platform. So please make sure to like and subscribe, and of course, turn on post notifications and leave a comment down below before you go. Check out our website at www.ecoreacademy.org. See what kind of interesting content we have there. We have full unlocked quizzes, notes sheets, and of course, just overall lessons with descriptions that go along with each and every single one of our videos, organized into their own separate course studies, all for you. They have progress checks and really neat features there overall to help you stay organized and literally go through an entire course to replace your school and also help you with school as well. So all you have to do there is make an account for free if you'd like to get all of the features. Then, of course, you can email us at eCoreAcademy@gmail.com. All of that contact info is on our website as well. If you have any questions, you can email us through that email, or if you just want to reach out to us privately. We also have all of our socials in the description box below. We have Facebook, Twitter, Instagram, and TikTok. Check out what kind of interesting content we have there. Our TikTok is just for jokes. It's going to be something completely off topic, just to really just take you guys out of your day, give you some interesting, just some really cool, funny videos. And then, of course, we have our social medias where we're also going to be posting extended information about our platform. All right, everyone. So that'll be it for today. I really hope you guys enjoyed. I had a blast making this video. This has been AJ, and I'll see you guys in the next one. Peace.